Hello gang, welcome to part 5 of our Rust beginners tutorial. In this and the next few upcoming videos, we will be taking a look at some of the concepts that are common to most programming languages and how they work in Rust. In this video, we are specifically going to learn about variables and the concept of mutability with respect to Rust. Before we jump into it, if you guys haven't subscribed to the channel, please do so as it helps me out a lot. If you guys have found the content interesting and would like to see more, please smash the like button and share this video with your friends who would benefit from this. Let's get into it. As mentioned in the previous video, variables store data for the program while it is running. By default, Rust makes variables immutable. This means that once a variable is initialized with data, it cannot be changed under normal circumstances. Let's see how this works in action. First, we open up the terminal, change into a directory, create a new project using cargo new. I'm going to call this variables. You guys can call it whatever, it doesn't matter. Open up the project in Visual Studio Code. Okay. And open up the main.rs file. Now, if we see here, we will be changing the contents of the main functions. So let's enter x equal to 5, print ln. Okay, and now we are going to assign x equal to 6. And now let's try print ln. Now let's try what happens. Now you can already see that there is an error here. Cannot mutate immutable variable x. That is, we are trying to assign 6 to x when x already has a value of 5. So you can see here, let's actually just try running it in the terminal. Yeah, see now the compiler itself says cannot assign twice to an immutable variable. So, and the compiler does give us a solution. Consider making this binding mutable. That is, change x to mutable. So let's, at the declaration of x, let's change that to mutex and try running it and try saving it. Now the error is gone. Let's try running it. And as we can see, it has printed 5 first and then 6 as we'd expected. Now we will look at a different concept in Rust called constants. Constants, like immutable variables, cannot be mutated. Then you might wonder, why do we have constants? Can't we just work only with immutable variables? There are a few subtle differences between variables and constants. Firstly, constants are always immutable. This means we cannot add mute to make them mutable. We cannot use shadowing like we used in the previous video to make them mutable. Once a constant is initialized, it cannot be changed under any circumstance. You declare constants using the const keyword. The data type of the const value must be mentioned while declaring it. We will look into data types and the concept of data types in the next video. Constants can be declared in any scope, including the global scope. This means that constants do not have to be declared inside the function. It can be even be declared in, say, here. So let's look at how to declare a constant. Yeah, let's say const. Now the naming convention for consts is all capital letters and words split by underscore. So here we are creating a constant called 3 hours in seconds, which basically holds the number of seconds in 3 hours. But now we are getting an error. Like as mentioned earlier, the type for the constant has to be mentioned while declaring it. So we can call it U32. U32 means unsigned integer of 32 bits. We will learn about this in the next video, so don't worry about this. Now, say for example, we want to print, we can print this here, print ln. Now let's see, now let's try running it, 1800. Now, if we try to mutate, see now we get an error here. Because mute is a const, we cannot assign a variable to it. Let's see, let's try making it mutable. See, now we get another error here saying consts cannot be mutable. So that's how we generally. Well, one more thing about const is you cannot, the value of const has to be known at runtime. This means you cannot add something like x, where x is a variable. So it has to be either a number or an expression which the Rust compiler will know at compile time. So let's change this back to 60. This is an expression, or you could keep it equal to 10,800, or any value which the compiler can compile, which will know, compiler will know at the time when the program is being compiled, not while the program is being run. Now, constants are useful when you need to use hard-coded values in your program. It conveys what the value means for someone reading the code. Furthermore, if the value needs to be updated, it can be updated in just one place instead of multiple places. Say you're using 3 hours and seconds as a constant multiplier in multiple places. So instead of 3 hours, you need to make it 2 hours. So instead of going everywhere and changing the value, you just need to change it here, and it will get reflected everywhere. Okay, next we will get into this concept called shadowing, which we touched briefly upon in the last video. Okay, so now as we've seen in the guessing game video, you can declare a new variable with the same name as the previous variable. This is called shadowing. In effect, the second variable overshadows the first, taking any uses of the variable name to itself until either it gets shadowed itself or the scope ends. Let's see this in action now. So if we here in this piece of code, we first initialized x to be equal to 5. In the next line, we have shadowed x and initialized it to be x is equal to x plus 1. That means it will be 5 plus 1. Now we have created a new scope within the main function. Here we have multiplied the value of x by 2. That means x is currently equal to 6, and so 6 into 2. So x will be equal to 12. Now once the scope gets over, the value of x reverts to this this value of x, that is 6. So 6 will be printed here. Let's see this running. As we mentioned before, here the value is 6, but now this x has gone out of scope, whereas this x still remains in scope. So over here, the value will be 6, whereas here the value will be 12. Shadowing is quite different from making a variable mute. Whereas if you mark a variable as mute, you change the value of the variable. Shadowing creates a brand new variable by itself. This means we can change the data type of the variable as well. Let's just check this out. Yes, say for example, let str example underscore string equal to, say, hello. Now let's print this out. Now let's change the variable, change the type of the variable. Now we can put let example string equal to example string dot len. This will give us the length of the string. So currently HELLO has 5 letters. So this example will be 5. Now let's try printing it out. Okay, let's try running the code now. Yeah, see, it is first printed example string as hello, and in the next print statement, it has printed it out as 5. Now, if we try doing it with a mutable variable, like and we try changing this to, now we are getting an error. We expected string, but now we are getting use size, which is an integer size. Again, like we can try running it. So again, the error that we're getting is expected string, but found use size. Now, if we like what we did in the previous video, shadowing is generally used when we are converting like a string to an integer. Like if we take an input in the form of a string, if we want to convert it to an integer, that's when we generally use shadowing, but it can be used anywhere else as well. So I think that's pretty much it, guys, for this video. Thank you all for watching. Again, if you haven't subscribed, please do so. If you have any doubts or feedback, please mention it in the comments and I will definitely get back to you. If you found the content useful, please like and share the video. Thank you and see you in the next video where we will learn more about data types.